And they're now estimating that our galaxy alone has at least 100 billion black holes, which is why some afternoons you feel slightly depressed. Now, when you get to the bigness of the universe, things get very strange very fast. There's a galaxy called the Andromeda Galaxy, which is racing through our universe at 200,000 miles an hour. Stars do unbelievably strange things. There are stars called neutron stars. They are essentially what's called hyperdense, which means their gravitational pull is so strong that these stars are literally turning in on themselves. When this gravitational pull becomes so strong that it pulls the star in on itself, then its weight, density, mass, and volume takes on all sorts of strange characteristics. Here's an example. A neutron star weighs has a friend named SpongeBob. Unbelievable. The art police would make an arrest for that, just boom. Now, a neutron star weighs several hundred million tons. A neutron star weighs several hundred million tons and fits in a teaspoon. When you deal with the bigness of the universe, things get very strange very fast. Nothing is as strange as light, which comes from suns in the form of particles called photons. And photons travel at the speed of light. Now, yes, the speed of light is incidentally the speed of light. Now, at the speed of light, and the way that light travels in particles called photons, things get even weirder. Here's an example. Let's say you're standing in the street, and you see a car coming at you at 20 miles an hour. You elect not to step onto the curb this way or to step onto the curb this way, but you decide to turn and run as fast as you can away from the car that's coming at you at 20 miles an hour. We don't know why you do things like this. So you turn and you run as fast as you can away from the oncoming car, because when you run, you feel his pleasure. Now, let's say the car is coming at 20 miles an hour and you reach a top speed of 10 miles an hour. Now, when you were standing still, the car was coming at you at 20. If you reach 10 miles an hour and you look back, the car will now be bearing down on you at what speed? 10. Well done. Now, let's draw this just because I think oftentimes the drawings help. Here's you. And interestingly enough, you've grown dreadlocks for the occasion. Now, 10, 20 equals 10. And we all say this because we have what's called a Newtonian understanding of the universe. Isaac Newton, mechanical laws of physics. An object in motion stays in motion unless acted on by an outside. Flashbacks to 9th grade. We were taught that there are these rules that govern how the universe functions. Safe, predictable, plug in the numbers, and you'll get your answer. We were essentially taught what's called a cause and effect understanding of the universe. Certain things work on other things to produce and lead to certain results. Give me A, give me B, I'll give you C. The problem is, light travels at 670 million miles an hour. If you're standing in the street and a particle of light comes at you and you turn to run the other way, which raises a whole other set of questions. If you're standing still, it comes at you at the speed of light. If you turn and run 1 mile an hour, 10 miles an hour, 100 miles an hour, 1,000,000 miles an hour, and look back, that particle of light will always be bearing down at you at the exact same speed, the speed of light. Well, a man named Albert Einstein got onto this in roughly 1915. He said, wait. The more he discovered about light, he said, hold on, light doesn't follow any of the rules of our Newtonian understanding of the universe. Einstein said, wait. He essentially said the universe is not static. When it comes to light, there is no A plus B. Light just does its own thing. When you get to the bigness of the universe bends and it warps and it distorts, and it doesn't matter how fast you run away from light, it always will be pursuing you at the exact same speed. Well, as you can imagine, this is obviously his general theory of relativity was an absolute revolution in the way people saw the universe, because it was assumed that the universe had these predictable, predetermined ways that it operates. But with light, it simply doesn't follow any of those. The universe and its bigness is just plain weird. They've even found in our galaxy a planet which is racing through our galaxy at 67,000 miles an hour. At the same time it's racing through our galaxy at 67,000 miles an hour, it's also spinning, rotating at 1,000 miles an hour. This planet is called Earth, and this is why you should wear a seatbelt. Now, the Earth has a sun, or maybe we should say our sun has us. The Earth receives 99% of its energy from the sun. The sun converts for us 4 million tons of energy every second, and over an 11-year sun cycle, that energy output varies less than 1/10 of 1%. All of this at a distance of 93 million miles. 92 million miles, no life on planet Earth. 94 million miles, no life on planet Earth. Now, the Earth is unusual from other planets in that the Earth tilts on its axis at 23.5 degrees. Other planets in the solar system? Earth. Now, the question is, why does the Earth tilt? Well, if the Earth did not tilt, it would run the risk of becoming what's called tidally locked, which means one side of the Earth would get stuck facing the sun all the time, while the other side would never see the sun. So the one side of the Earth would get hotter and hotter and hotter until it could not sustain human life, while the other side would get colder and colder and colder until it could not sustain human life. So this 23.5 degree tilt of the Earth's axis is just exactly precise to allow this little blue and green floating ball to sustain human life, which raises the question, why does it tilt? It tilts because 40% of a gravitational pull that comes from the sun pulls it over. The other 60% of that tilt comes from the gravitational pull of a little rock we've come to know as the moon. The moon and this pull is what allows planet Earth to sustain life. No moon, no life, which raises the question, how did we get our moon? Scientists believe that our moon was some sort of meteor or asteroid that was just flying through our galaxy and essentially got stuck in the Earth's gravitational pull, making it the cosmological equivalent of, oh, all right. But I have a dark side. Hydrogen on planet Earth must convert 1/7,000th of its mass to helium continually for the Earth to sustain human life. 0.007, 0.008, no life on planet Earth. 0.006, no life on planet Earth. Our atmosphere is 21% oxygen, 23% oxygen, no life on planet Earth. 19% oxygen, no life on planet Earth. The ocean, our oceans are 3.4% salt. The oceans are 3.4% salt, which is the exact percentage of salt in the human bloodstream. 4% salt in the oceans or our bloodstream, no life on planet Earth. 2% salt in our bloodstream or the oceans, no life on planet Earth. This is, by the way, called the science of fine-tuning. And there are hundreds and hundreds and hundreds of these unbelievably precise numbers that all add up to life on planet Earth. Carbon levels, gravitational force, the density of particular minerals and primal elements that all add up perfectly. The metaphor is simply this. It's as if there are these dials to create and sustain life on planet Earth. It's as if there are hundreds and hundreds and hundreds and hundreds of these dials, and every single one of them has been adjusted just perfectly. And this one goes to 11. And every single one of them adjusted just perfectly.